All right, I have got a very specific debugging task that I need to do. And it involves a new class in the C64 OS Toolkit called the TKDatePick class. So what I'm going to do is it's not working right, and we're gonna look at what we want to. We're just gonna look at how to debug why this isn't working right. First thing I'm going to do is I'm going to power off the machine because powering off the machine will clear memory. So now we'll power the machine back on. And the first thing I'm going to do is I'm going to boot into C64 OS to show what it looks like right now. And while that's booting up, I'm going to grab some documentation here. Right. So this actually is what we're working on here. So this is a date picker. We're actually doing this one here. So this is a date picking utility. The date picking utility embeds a date pick class, and that class embeds a year picker, a month picker, and a date picker. Okay, so that's what it should look like. And what we're going to do is go over to our utilities here. And then we're going to open the date utility. Okay, so as you can see, we have our utility and we have our date pick class, and it's not crashing. And in fact, this is working. So we can click through this guy here. But the problem is, of course, that what has happened, where's the month and where's the date, right? Okay, so now that once that's loaded in, we're going to reset the machine. And of course, by resetting but not power cycling, the contents of memory are left pretty much intact, except for everything below screen memory. So everything below 400 has been reinitialized, but everything in main memory should still be there. So we will open our monitor. The monitor is at C1000. That is actually above the area of memory that C64 OS allocates. So it's going to clobber, so C1000 is going to clobber part of the C64 OS kernel, but that's okay. Okay, so if we recall, the button had the year 2022. Pretty sure I left 2022 as the button text. So we don't know where that TKDatePick class is in memory. So to find that, I'm going to search for 2022, and I happen to know that the string that displays as the title on the years button is actually an instance. It's an object variable of the TKPick object. Okay. All right. So so we'll go. So using our monitor, we'll say hunt, starting at 2000, because I know I'm not using memory as low as 2000. In fact, I can prove that. Let's prove that first. We'll say we'll look at memory starting at 2000. Okay, so here we can see that memory starting at 2000. This is just the regular, the initial pattern of memory from when we turn the machine on. Okay, so now we're going to hunt from 2000 up to 8000, which is where the monitor starts. Sorry, it's not where the monitor starts. It's where the C64 OS kernel ends, approximately. So we're going to hunt from 2000 to 8000, and we're going to look for 2022. Okay, so we got lucky there. There's actually only one instance of 2022, so it's at page 34. So now what we're going to do is we're going to look at the memory of page 34. And here's what we are going to do. So now I'm going to point out some features of this. I happen to know that the date utility allocated 2 pages of memory to be used as the memory pool out of which to instantiate all of the Toolkit classes for the views that make up the user interface in the date utility. So this 2 is this 2 is what initializes the memory pool, indicating that it's 2 pages long. So immediately following this 2, we have a standard malloc header. So a malloc header is 3 bytes. The first byte is 0 if the chunk is unused, 1 if the chunk is used. So this chunk is used, and then we have 2 bytes, 16 bits, to indicate how long this chunk is. It's little endian, so this chunk is 27 bytes long. That's hex. And the high byte is 0, so it's just 26. So what that means is we can take our hex calculator and we can convert 27 to decimal. We get 39. Now, next what we're going to do is we're going to look at the documentation of our Toolkit classes. So here I have a table of the built-in classes, and the TK view has an object size that is 39 bytes. So this 27 is 39 bytes. That's because the root view is a TK view. So that part makes sense, right? So what this means is that, so we have our malloc header here, and then immediately following the malloc header, we have 39 bytes. So this is the instance of the root TK view object. So what that means is that we can simply read through these to figure out what the various instance variables are. So the first, so TK view is a subclass of TK obj, and the only thing that TK obj the only instance variable of TK obj is the ISA pointer. The ISA pointer is what tells the toolkit, it gives an object a pointer to its class definition. So here we have, again, little endian, so 9bf6, that is somewhere inside the C64 OS kernel, and yeah, it's to the instance, it's to the class definition of TK view, and TK view is one of the built-in classes, and so it's somewhere inside the C64 OS kernel. So next, next what we can do is we can simply start reading down the instance variables of TK view. So for instance, TK obj has 2 bytes for the ISA pointer, and then after that we start getting all these instance variables in TK view. We have a next responder, 2 bytes. And then we have these node properties, a parent 2 bytes, child 2 bytes, sibling 2 bytes, a tag 1 byte, then we have sizing properties, and so on. So we don't, the only thing what we really want to do is we want to follow the node tree, right? Because the UI is hierarchical. So what we have is a root TK view, and the very first child of the root TK view, this is a very simple utility, is the TKDatePick class, and then a sibling of the TKDatePick class is that default blue button, and that's really it. But then inside the TKDatePick, it has other classes. Okay, so here is the ISA pointer. Here is the next responder. Here is the parent, that's null because it's the root class. It's the root object. Here is the child, first child. And here's a sibling. The root class doesn't have a sibling. So first child, 34.2e. So 34.2e is right down here. So 2, 8, 9, A, B, C, D, E. Okay, so here is, this is a pointer to here. It's the first child. Now, this is the first byte of the memory, but it should be preceded by a malloc header, which is 3 bytes long, and it is. Now, how do we know that? We have an O1, just like this O1. So this is a malloc chunk that is allocated, and then we have 2 bytes. High bytes 0, low bytes 2D. So let's confirm that. So we'll say hex 2D. Convert that to decimal. That's 45 bytes. And if we refer back to our documentation, we will find that a TKDatePick is 6 bytes bigger. I can show that right here. So a TKDatePick is 6 bytes bigger than a TKView. Now, why is that? Because a TKDatePick inherits directly from a TKView, so it's the same size as a TKView. It's 39 bytes, plus it adds 6 more bytes of instance variables, so it should be 45 bytes. And indeed, 2D is 45 bytes. So this is definitely the object, this is definitely our TKDatePick view. So, a TKDatePick is going to have all the properties of a TKView, which has all the properties of a TKObj. So these 2 bytes are the is a pointer. 36, that's just a little further down or a little higher in memory than this. Why? Because we had to dynamically load the TKDatePick class into memory just before allocating the memory pool to instantiate it. So that makes sense that 34 and 35 are the 2 pages for the memory pool, and 36, well, that's the first page where the class is instantiated. So that's kind of cool, right? All right. Next, we're going to have a bunch of TKView properties. So we really want to review our TKView properties. And one thing I'm going to check is the TKDatePick should make itself 1 high by 14 wide. So we're just going to follow these. So that's the ISA, next responder, first child. That's parent. Does that make sense? 04, 0, 1, 2, 3, 4. That goes back to the root view. First child. So we'll come back to this because that should be the year button. Sibling. That's going to be the blue button that is a sibling to the TKDatePick. Okay. Next is the tag. There is no tag. That's 1 byte. All right. Now we're into sizing props. Here's our tag. So this is off, top, off, bot, absolute bot, and height little endian. So there's 1, and the next, and the high byte is 0. So the height is 1. Okay. next is that correct? No, my finger was actually down a little too far. That 85 is not right. Okay, so there's the high. Okay, so next is off left. That's 0. Off right, that's 0. Absolute right, that's D. Okay, so that D, let's just put the cursor on that D. So that D is absolute right. That's the absolute right edge of this view. Should be, let's just see what D is for a second here. D. So 13. That's 0 based. So that should be right. It's 14 wide. So D is the index. It's 13 is the index, and then width. So that's one more. So the width is 14, but the actual index of the right edge is the width is 14, but the actual index of the rightmost edge is 13 because it's 0 based. So E0. Okay, so it is in fact the correct width. And then there's some other properties that I don't care all that much about, including getting down to here. So this is 2, 0, 2, 2. That is the string title for the year button. And then 08. That's the string title for the date, which is today's date, which it is the 8th. So let's, so that part's right. So let's now pop back up to, well, back up to here. So here's our malloc header. There's our is-a pointer, next responder, parent, first child, 34.5e. 34.5e. So we have 5, 8, 9, A, B, C, D, E. Okay, so let's just plop her there. Here is our malloc header. It's allocated. 3e. So let's check out how big 3e is. 3e. 62 bytes. If we check our table, a TK button is 62 bytes. So this is definitely a button. Well, it is a button, but this confirms that it's the correct size for a button. So now we have the is a pointer to a button, and 8b is going to be somewhere in the kernel again because a TK button is a built-in class, so that makes sense. Next we have a next responder parent, 34 2e. That's this guy, correct? That's its parent. Next is its child. It doesn't have a child. However, next is the sibling of the year button, which is not displaying. So we can see that it is instantiated. So now let's take a gander at 34.9f. 34.9f. It's going to be right here. 1e, 01, it's allocated. 3e is the size of a button. So we've got another button. 8b66 is the is a pointer. 8b66, 8b66. That's the is a pointer for the second, this is for the, say, the month button. Okay. Now we have the next responder. No. 34.2e is the parent. It's the same parent. 34.2e. It's the same parent as its previous sibling. It doesn't have a child. 34E0, that's the next sibling. That'll be the date button. But now we get into the weeds here, right? So 4D is a tag. Now it should be a month tag. Okay? So actually, this 34 is a parent, child, nope, parent, where are the frig? You see, I got confused. Hold on here. So 4D is a, okay, EO34 is the sibling. EO34 is the sibling. 34-2E was the is the parent. So we should have another 34-2E. Okay, so here's 34-2E is the previous sibling's parent. No. 34-2E is, yeah, the parent. 0302 is the parent. What the heck is 34-2E? 34-2E? Let's just do this again. There's your is a pointer. There's your next responder. There's your parent. Okay. So there's a parent. Child? Doesn't make sense, does it? Sibling? (34-5E). That should be the parent. Should be the child. Oh boy. See how easy it is to get lost? It's super easy to get lost, isn't it? Okay, where did I come from? So let's do this again. So 34-2E is the TKDatePick. Right. Right. Okay. So here's a button. Here's a button. Responder. Parent 34-2E is the date pick. The button doesn't have a child. 34-9F is its sibling. 59 is its tag, and there's its tag as a Y. Okay, so here's this Y is the tag on the year button. Okay, then we'll go 34-9F is here. There's the next button. Its parent is the TKDatePick. It has no child. It has a sibling. 34-EO. It has a tag, M. Right. Okay. Whew. At least we can get oriented now by the Y. This Y is the tag on the year button. This M is the tag on the date button, the month button, and this D surely is the tag on the date button, because I've tagged the 3 buttons because they use the same click callback, and then the callback uses the tag on the sender to figure out what it should do. Okay, so that all looks right. So the point is that the year has a sibling. There's its tag. It's 1 byte. So after tag, we have off top 0, off bot 0, absolute bottom is 0, height is, holy guacamole, its height is 0. That's not right, is it? That's probably the problem right there. And then after it has a height of 0, it has an offset left of 6, which is correct. And then it has an offset right of 0. It has an absolute right of, hold on, 6 was its offset left. 0 is its offset right. 0 is its absolute right. That's probably not being computed because its height is 0. And then 4 is its width, which is perfectly fine. But now let's take this M, which is the tag, and immediately before the tag is the sibling pointer. So EO34 Does that make any sense? 34 is the high byte EO. Okay, so here is the start of the next button, date button. Here's our 013E. That's the malloc header. Okay, perfect. Okay, so here's the is a pointer, next responder, parent, 34.2E. That's the TKDatePick. Child doesn't have a child. Next sibling doesn't have a next sibling. Perfect. D, that's its tag. Perfect. Next we have our offset top, offset bottom. That makes sense. Now we have our absolute bottom, 0. Actually, that might not be right either. Absolute bottom should be 1, I think. Same with the one up here. I think absolute bottom isn't right. Actually, let's check that. Let's check that one first. So here's our year tag. So following the tag, we have off top, off bottom, absolute bottom, height of 1. Okay, so off bot being 0 is probably okay. Back down here, here's our tag of M. Here's our offset top, offset bottom, absolute bottom. Height is the thing that's fucked up. Yeah, it should have a height of 1, but it doesn't have a height. So that's probably why it's not showing up. Now, I don't know why it doesn't have a height. I don't know why. Okay, now let's go pop down here to our date again. Here's the tag of date. Those are the off top, off bot, absolute bot. Height again is fucked up. That should be 1. Off left is B. That's correct. Should be at least close enough. Off right, 0, fine. Absolute right, fine. Width, 3, fine. But it doesn't have any height. So I mean, the problem is that the second two buttons don't have any height. So let's go now. See where we are. Do our so let us now load up the TKDatePick class and see what happens. Let's jump down here to init. So here's how this works. We init, we call the super, so this is the init of the TKDatePick. So we call its super classes init method, preserve temporarily the this pointer, because we're going to make sub buttons, so we preserve temporarily the this pointer. Set the resize mask so that it resizes its children. If the TKDatePick gets resized, it'll resize its children. It's going to anchor to the top, not the bottom, the left, not the right. So that's top and left. The height of the TKDatePick is 1. The width of the TKDatePick is 14, which is enough for 1, 2, 3, 4 years. 5 for a dash. 6, 7, 8. Oh no, sorry. These are buttons. So it's 5 for the cycle button, the cycle icon, plus 4 digits. A space. A cycle icon, 3 characters for a month, a space, a cycle icon, and 2 digits for a 2-digit date. That's 14. Okay, so the width is 14, that's correct. Next, we start to instantiate sub elements. So this TKDatePick class is an example of a class that uses composition. So it doesn't subclass something and try and recreate buttons. It actually creates buttons and adds them to itself. So we're going to create a button, and we're going to initialize the button. And then we set the padding, the left padding, that eliminates the space between the label and the icon. The width is 5. The type is a cycle button. Minimum value of 0, maximum value of 255. We tag it Y. We could see that in the code. We set it to be a continuous firing. So a button is a subclass of a control, but the control, so this is a property on the superclass of button, so that when you click it and you hold, it will continuously fire. Then we set its target. So what's the button going to call? So the target is going to be date part cycle on the object, and we pull the temp this. So we get a pointer to this. We get a pointer to the TKDatePick class and its method offset. Okay, and we set that as the target on the button. So the button is going to call a method on its parent class. Cool, very cool. That works, by the way. We can see that in the UI. Next, we set the title of the button, and we're going to set the title of the button to be a member variable of this. So the TKDatePick class has member variables that get updated, and the title of its button is coming from an instance variable of its parent, which is kind of cool. Very object-oriented. I like it. Okay. And then what we do is we say, okay, we're going to append this year button to its parent, temp this. Next is where things go off the rails. Because we instantiate a new button. That'll be the month button. We set its padding to 0. We set its width to 4. We set its offset left to 6. Set its button type to cycle. Its min value to 1. Its max value to 12. It's tagged to M. That part worked. We set it as continuous. We set it. We set its target to be the exact same depart cycle on its parent. But we don't set its target. We don't set its title yet, because it'll be set later, because it uses months, not ints. So for some really fucked up reason, the height is not being computed properly on these guys. And I don't know why that is. So we're going to manually set a height? That doesn't make any sense to me. Ah, look at this! I see the problem. Look, we're not instantiating the buttons. So their heights are all 0. Ha ha ha, that's the bug. That's the bug. Look at this. We take the year button, we initialize it. Then we override a bunch of its properties for what we want. Then we come down here and we make the month button, but we never initialize the properties of the month button. And then we simply override some of them. Very, very easy. Very, very easy. You know, I never noticed that. So we're going to copy that. Copy that to here. I'm going to come down here, and sure enough, we didn't initialize the date button. That's it, folks. That's going to do it. That's going to do it. All right. Oh man, that was a wacky one, wasn't it? TKDatePick.a. Save that. Now, we have just changed offsets. Here's a tricky part about the C64 OS relocation. We don't know whether E2 is still an appropriate place to assemble to. So we're going to comment that out. We're going to assemble it to 1000 TKDatePick.r. And I'm actually going to cut this part of the video out because it takes for goddamn ever to assemble. All right. So now that I've assembled it, I'm going to drop the basic, and I'm going to run the C64 tools relocator program, TKDatePick.r. Okay. So now we're going to pray that additional initialization code didn't cause this class to overflow 4 pages, but it might have. It might have. Okay, so it's going to load the class into memory. Basic. Come on, basic. Okay, it's 1012 bytes. That's handy. We didn't overflow. So these are available pages that we can assemble to. All right, so the reason we did this is because, as you can see, E2 is no longer available. So I'm going to assemble it this time to F3. Why not? It's available. Okay, so F3. So E2 is not available, F3. Now, F3, let me make that note of that, just so I don't forget, F3. So I want to point out that when I assembled it, that caused the label count to go way sky high. And there's no way to get that to go back down, except for to reload from disk. So I'll go TKDatePick.A. Okay, it goes back down to 266, much better. I also saved it before doing this comment. So we're going to set that to F3, and thankfully it's still 4 pages. We're going to save that, TKDatePick.A. Don't overwrite. We want to save that as the source code file, A. And we're going to reassemble it. Very important we don't overwrite our source code file, TKDatePick.R, relocatable object file. And I will come back shortly. All right, so that has been assembled to F3. And now we can boot back up into C64 OS, and we can see, we should see now that those other buttons appeared because they have a height of 1, which is pretty cool. Also, the fact that their height was 0 was causing their parent to skip resizing them, which is kind of cool. Alrighty, we'll just go over to utilities, and we'll pop open date. Look at that date! It fucking worked. January 8th, 2022. Watch this. Boom, 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 boom. Isn't that cool? Sept, Oct, November, December, January again. Okay, here's cool. Let's try this. So, 2022, is this a leap year? We'll just pop up here. How many days we got? 28? 28? 28, okay. So 28 to 1. Therefore, not a leap year. How about next year? No? How about the year after that? Yeah, look at that! Look at that! 2024 must be a leap year. Look, we got 29th. Now let's go back from 2024 to 2023. Look at that! It flicked back to 28. Oh man, that's cool. Leap years are handled. Oh fuck, that's cool. Alright, how about we go forward from February to March? So March has 31 days, but now we'll go from March, we'll go back to February, and went to the 28th. So now we'll go forward to March, we'll go to 31, but we'll go to a leap year, 2024. So now we'll go from March back to February, and it went back to 29. Isn't that just fucking phantasmagorical? All right, thanks for watching. That was a sneaky bug, but we got to figure it out.